Question number 1. A projectile is released with a speed u at an angle to the horizontal. With the aid of the diagram, show that the time of flight is equal to what? To the expression you can see on the screen right now, where the g you can see in that very expression, like we were given that very g to be what? To be the acceleration of what? Of free fall. That's what the acceleration due to gravity. Now, because when we are talking about projectile is one of the questions the Waec sets every year. So because of this, what we are going to do now is to what? Is to analyze projectile very well, even expanding it more than what we would actually need here, so that anytime we see questions on projectile, we're able to solve them very well. Now, the motion of a projectile is always through a parabolic path. Just like if you throw a stone upward, I tell you this very stone would pass through a parabolic path. If you throw a rubber ball what against a wall, you realize that this very rubber ball would bounce back with what we passing through a parabolic path. Do you understand? So it is not just a straight line, which we would imagine it to be. If you throw a stone, you would imagine that very stone to what to pass through a straight line. No, it doesn't happen like that. It passes through a parabolic path. Now, this is the parabolic path in this very question, for example. Now, after we've known that, we are told that what a projectile is released with a speed u at, so this very place, the projectile is being released here with a speed u, So this is the what? This is the speed. This is the speed. I want to illustrate the speed. So that's what we mean by what? That's where we have our what? Our u. So after we've known that, the next thing is what? U at an angle y to the horizontal, right? So let's illustrate that very well. This is the okay. This will be the what? This will be the horizontal component, which we usually call x, and this would be the vertical component, which we usually call y axis. So after we've known that, the angle between this very u, just like you can see in this question, and what x is what? It's this very y cross that very y. So with this, we can actually get the answer to this very question. Now, the only thing you would need to know so that you can get the correct answer to this very question is what we mean by the horizontal component of the velocity of this very projectile, and the vertical component of the velocity of this same projectile. I'm talking about the horizontal component of that very velocity, either this one or any other projectile in the world. I want to tell you that the horizontal component of that very velocity would not change. But if you examine the vertical component of the velocity of that very projectile, you realize that it would vary throughout that very motion. Just like what you can see here, it is usually illustrated like this in your textbooks. You will see something like this, you see something like this. Okay, in this very point also, you will see something like this, you will see something like this, and you see something like this. Around this very side also, you see something like this, and you also see something like this. Do you understand? Now, I want to tell you that the arrow you can see around this very side, this very arrow you can see here, it's talking about the horizontal component of that very point, of this very point you can see here, this very point here. Okay, let me use another color so that you can see that very point very well. The horizontal component of this very point. Understand? And this is this very one you can see here is talking about the vertical component of that very point of the projectile when the projectile is around that very point. So I'm talking about the second one also here. The second one you can see here also, this very point here. So the horizontal component is just like what I explained that very time. This is the horizontal component, and this would be the second one you can see there would be the vertical component. This is the vertical component of that very point. So just like that. Now I want to tell you that the horizontal component, if you check your textbook or things like that, realize that what they will put there as the horizontal component would be u, because u would not vary. I tell you, the horizontal component of the velocity would not change throughout the motion, just like what I said the other time. This also will be u. This also will be u. But you realize that when you are talking about these very vertical components, you realize that they would give you something like V1, you see something like V2, you see something like V3 here. The reason is that what? It changes throughout the what? The motion. So just note that. Now, because the horizontal component of that very velocity would not change, so we can't use that to what? To get the time. I don't know if you can get this. Okay, if you're around this very side, if the when the what when the this that very ball that very projectile is around this very side, you can't know that it's around that very side because what? Because the horizontal component is not actually changing, but the what? The it is the vertical component of that very velocity that is changing. Do you understand? So it is that very thing that is changing that would be that would can use to what? To get the time of that very place. Just like this very side also that you can see this very just like this very side also. You can actually get the what? The time in which the projectile is around that very side. Why? Because the horizontal component at that very side is still the same thing as the horizontal component of the other side when the what? When the projectile is around that very other side. But when you're talking about the what? The vertical component will be changing gradually. So that would help us to know the what? The time at that very particular time. So it is the formula of the what? Of the vertical component of that very what? Of the vertical component of the velocity that would use to what? To get the time of flight in this very projectile. I hope someone can understand this. Please understand, because that's exactly why people fail projectile. Now, the vertical component of the velocity here would be what? Would be Vy equals to what? I understand. I know that you should understand what we mean by the vertical component. So that's what u what? U sine what? U sine. You know, we are not given theta here. We are given something like this. So that's across the y. So note that. Now, back to the question. You would see that what? We are told that what? The time of flight, right? So, before we can know do this very time of flight, we must understand something, and that's what? Maximum height. The what? The velocity at this very maximum height will be zero due to what? The acceleration due to gravity, and that's why the object would what? Would fall. It is that gravitational force that would pull the object back to the ground. So, at this very side, the velocity here would be what? The initial velocity. To understand this, let me just make that very initial velocity to be so to be 6. Do you understand? So now if this very what? If this projectile reach the what? If it reaches the maximum height here, you would what? You would realize that the velocity would change from what? From that very 6 to what? To 0. So that means that around this very side it could have changed to what? Maybe 4. Around this very side it would have changed to maybe 5, maybe 2, until what? Until it gets to what? V equals to 0 here. And why is it that that very V is equals to 0? Just like I said the other time, it's because of what? The gravitational pull of the earth, the gravitational force. It would what? That means that if there is nothing like this very gravitational force, if you throw an object, it might not come back again. But it's because of this gravitational force that is drawing that very thing back towards the earth. So it would get to a point in which the velocity here 6 would change to what? To 0. So, and that's the what? That's the maximum height. And from that very maximum height back to the ground back, it would what? It would fall with the what? With the influence of that gravitational force. That's why if you actually want to write, okay, let me introduce what? One of the equations of what? Motion in this very question. So that's what? That's what, V equals to what? V equals to U plus what? Plus AT. And thank God we've actually known our velocity to be what? Like the initial velocity of the vertical component to be u sine y, right? So we'll just write our final velocity will be what? Would be what is that u sine y? So you write it here. You write, this very place is what? It signals the initial velocity. So you just write u sine that very y. You cross it. Now you don't really know if you would plus or minus. Now the reason why you don't know is this: if it's actually going towards the what? Towards like if it's going up, the influence of gravity will try to what? Will try to pull it down. Let's just imagine it. The object is going towards this way. It's going towards the what? It's going upwardly. Now the gravity is what? Trying to pull it down. So because they are not at the same direction, it is what? They are opposite to each other. Because of this, the gravitational force would what? Would have minus. So that would be, as the acceleration due to gravity, I'm sorry, would have minus. That would be minus g. So you multiply that. That would be the acceleration, right? You replace with that, and the time, you multiply it with time. So with this, you'll be able to solve this. So that's when this very object is actually going upward. But when the object, that projectile, is coming down, it's what? The g will be plus, because what? The direction will be like the same. They will be, okay, you see, this will be the direction of g, and this will be the direction of the object. So that means that what? It is plus right now. Do you understand? But I'm talking about the other time. It was because of the different direction, the g would be minus. Now, the formula we are going to use right now, it will be what? Will be u sine theta minus what? Minus gt. I hope you understand that the reason why that very thing, we have minus here, is because of what? Because acceleration due to gravity is acting to like acting at opposite direction to that very what? That very motion. So it will take there will be a time in which this very acceleration due to gravity would have what? Would have influence on that very object, and the velocity would change from its normal velocity to zero. So at this very and that is what? Around the maximum height. Now, I want to tell you that what? The time in which the projectile will use to get to the maximum height, and this very same projectile would use from that very maximum height to the ground back, is the same thing. It's just times two. So what we will now do now is to what? Is to get the time in which the projectile would use to get to the maximum height. And after we've gotten that, we can now what? We can now use 2 times that very time to get our what? To get our time of flight. That will be the total time in which the projectile would take. So with this, you can just say our v equals to 0, because at the maximum height, v would be equals to 0. So the initial velocity, you write it down, that's u sine theta. Okay, actually it might not be theta here, it is what? It is actually y. But okay, let's continue. Minus gt. So we'll replace theta with this very y later. I'm sorry for that very mistake. So we'd have what? To get this very question, would have to what? To take gt to the second side. So that would give us our what? Our gt equals to what? Equals to, so what do we have there? We have u sine theta. So with that, you can actually divide both sides by what? By the acceleration due to gravity. So t would be what? Would be u sine. So don't forget, the theta here is not theta, it's what? It's y here. So you divide all through by what? By acceleration due to gravity. Now we've not gotten the answer. Now I told you that what? This is the time in which that very object gets to what? In which that very object would get to this very place, would get to the maximum height. Now from the maximum height back to the ground is what? It's still the same time. So what you just need to do now is to what? For you to get the maximum the time of flight is what? Is to what? Is 2t. So if you actually put 2t here, and you would like to what? To verify your answer, you see that what? The answer here, you just check it. That's u 2u sine y, that's divided by what? G. And if you check that very question, you see that what? We got exactly the same thing. And even with the aid of what? Of the diagram, we've actually illustrated it. See, please try to what? Try to add the diagram and also what? Solve it just like this. Please, if you've not subscribed, click the red subscribe button for more videos just like this. Question number 2. The horizontal component of the initial speed of a particle projected at 30 degrees to the horizontal is what? 50 meter per second. Now, if the acceleration of the free fall due to gravity is 10 meter per second square, determine the initial speed and the speed at what? Maximum height reached. Now, the formula we are going to use here is that what? The horizontal component, right? So the horizontal component of that very speed will be Vx equals to what? Equals to what we mean by what? Our initial velocity, initial speed, and what? And cos theta. So that's the formula. Now, if you try this, you do what? In that very question, you see that what? Our horizontal component has been given to be what? To be 50 meter per second. we've been given that to be 50 meters per second. Now, our u also, we are actually told to look for u. If you actually take this question, you see that what option like question A is based on initial speed, so we'll leave that. So that's cos what? We have cos 30 degrees. Now, to solve this very question, you just have to what? Just have to write 50 meter per second. You divide all through by what? By cos 30 degrees. Now, this would give you what? The initial speed. Now, the initial speed now would be what? The initial speed would be, if you try this, if you try your calculator for what we mean by cos, for what we mean by cos 30, you would get something like 0.866. Now, solve all this, you would get your final answer to be 57.7 meters per second. Please don't neglect meters per second. It's very, very important. Now, option B, we have what? Speed at maximum height reached. So that would be, I already told you that what? At maximum height, the speed would be what? 0. So just write V equals to what? Equals to 0. And I told you that what? The horizontal component would not actually change throughout the what? Throughout the horizontal component of that velocity would not change throughout the motion. So that means that the horizontal component also will be the same thing as what? The initial component at that same point, at that maximum height there. So we have Vx to be what? Vx to be, we are given in the question to be what? To be 50 meters per second, because it doesn't change. So it is the initial horizontal component of that very velocity that will still be used, even that will still be observed even at the what? At maximum height. And the what? The vertical component here would be what? Would be 0. Question number 3. In an electrolysis experiment, the ammeter records a steady current of what? 1 ampere. The mass of the copper deposited in what? 30 minutes is what? 0.66 grams. Now, calculate the what? The error in the ammeter reading. So we have the electrochemical equivalent of copper to be what? 0.00033 grams per what? Per coulomb. Now, I want to tell you now that this very question, we've actually been given the what? The current, right? But we want to test, we want to actually know the what? The real current. And it is gotten through just a formula. We use a formula now to get the real current. The ammeter has a problem. Do you understand? Instead of it to be 1 ampere, it should be another thing entirely. But we can actually get the what? The steady current in which the ampere should record with all these other values. So what we just need to do is to what? Is to use this very, very formula. That's what? The mass equals to what? The chemical equivalence, that's Z, and then we have our I, that's the what? That's the current, and we also have T, that's what? That's the time. So with this, you'll be able to get your answer correctly. So now let's start that. We'll make I the subject of the formula, because that's exactly what we would like to get. So that will be what? M. So to get rid of T, it will be that you will divide M by T. And then to get rid of Z also, you divide M by Z. So write Z also here. Now that would be equals to what? That would be equals to I. So with that, let's write what? Let's write I equals to. So what is that? That's the very M. The mass given to us, we have 0.66. Do you understand? So you divide all through by what's the chemical equivalent? The chemical equivalent is what? 0.000 3333. So now you have to divide also by what's the time? The time you are given that what to be the time? You are given 30 minutes. Now don't forget that 30 minutes will be converted to what? To seconds. And if you want to convert minutes to seconds, you know that you just have to multiply that very minute by what? 60. So that's just what we will do. And with this, you will get your final answer of I to be what? To be 1.11 ampere. Now, this is the thing. You must not stop here. This is not the final answer. You were told that what? Calculate the error in the ampere reading. So that means that what would actually subtract this very value from, or you would subtract the value of what this steady current from it. You see, the ammeter here records what? Records 1 ampere, and we've got actually gotten 1.11A to be the answer here. So what you just do is to what? Is to subtract to get the value of the error. So that will be 1.11 minus 1 ampere. So that would give us our answer to be 0.11 ampere. And that's just it. We finished it. Please don't copy. Try to understand the concept and what do it. Please, Sean, examination malpractice. Question number 4A. What is Brownian motion? When we're talking about Brownian motion is what? Is an irregular, constant, and rapid motion of tiny particles. This Brownian motion was discovered by a biologist, that's Robert Brown. He discovered this by observing thin pollen grains. When he suspended these pollen grains in water and he checked these pollen grains under a microscope, he realized that though the water were perfectly still, but at the same time the pollen grains were moving around about they were moving around just with a zigzagly. They were moving around zigzagly inside the same perfectly still water. It was after some time, that's after some years, that Albert Einstein and another person, this is independently, they did it independently. They were able to get the reason. Number one, it proves the existence of of tiny particles of matter. That's the molecules, just like the molecules of water that could not be seen, and it actually causes the pollen grains to move zigzagly. The main thing is this: the force in which these very molecules of water, the molecules of water exert on these very pollen grains. There will be a point in which there will be a less force. Do you understand? The molecules of water, there will be a less force. So it is this very area that there is a less force that these very pollen grains would shift to. So this very process would continue, would repeat itself, would continually repeat itself until you realize what we mean by this very zigzag motion. Exactly what Estani said. And the second thing is that even with what I just said, you should know that it gives an evidence that these very molecules are they are in constant state of random motion. Question number 5. A mass of 11 kg is suspended from a rigid support by an aluminium wire of length 2 meters, diameter 2.0 millimeters, and Young modulus 7 times 10 raised to power 11 Newton per meter square. Now, determine the extension produced. We are actually given G, and we are actually given the pi. Now, to solve this very question, we must know the formula that connects Young modulus with stress and strain. So that's what we are going to use right now. So this is Young modulus, and it equals to what? It equals to stress over over strain. Now, with this, I expect you to know that when we are talking about stress equals to what? Stress equals to force over over area. And we also know that our strain will be what? Our strain equals to what? To E over L. That's the elastic limit over over the length. So with this, we can actually rewrite the formula to be what? To be FL over over E. So this is the formula we're going to use to solve this very question. But before then, we must actually know those things we actually need. We must actually know how to get those things we actually need. So what is the force there? Our force we've been given to what? We are given force. That's the mass. So, and you know force equals to what? M times A. That's M times A. That's M times acceleration. So this very A here will be acceleration due to gravity. So we can actually write our M to be 11 times what? What's E? We are given it to be 10. If you check this very question, this is it. We are given the acceleration due to gravity to be 10. So you can just write it here, and the answer is what? Answer will be 110, 110 what? 110 Newton. So we've gotten F like that. So that's the force. So what is the area? That's the next one now we'll get. Area, the area now. How to get area is what? The formula to get that very area is what? Pi r square. If you check it very well, you see that what? It's what? We're actually dealing with what? Aluminium wire. So the the area will be pi r square. And what is the what is the radius? We're actually given the diameter here, so we have to what? To get the radius, would have to divide the diameter by 2. So we have 2 millimeters here, right? So we can actually divide it by 2 to get the radius, and the radius will be 1 millimeters. So that means that now another thing is this: after that very 1 millimeters, don't forget we have to convert that very 1 millimeters to what? 2 meters. Do you understand? So that means that our area now would be pi is what? Pi equals to what? 3.142. That's it. You can't actually forget. You don't forget that. Now the radius now, if you convert 1 millimeters to what? To meters, you would have what? You would have 0.001. So you would square. You would square that. And if you actually punch your calculator, you get the area to be what? To be 0. So that's 0.0000000. You would have what? You would have 3142. So that will be in meters per second. So don't forget the meter per second. So after we've known the area, I think we are good to go, because we are actually asked to what? To look for the extension, and L it's actually given to be what? To be 2. So we can actually go with this. Now we have to make the extension the subject of the formula instead of y. So it will be what? Let's write it first. So that's y equals to what? F what? L over what? Over E. So make E the subject of the formula. That would give you what? That would give you E to be what? To be, you would have E to be FL over what? FL over what? AY. Where this is the what? Is the Young modulus. So now let's substitute our value into this very equation. So we have the force to be what? We have the force to be 110. So just write 110. So multiply 110 by what? With this very L. L is what? We've actually known L to be 2. As I was telling you the other time, that's it. The length of the wire, 2 millimeters. So over what? Over. So what is the area? We've actually gotten the area to be this, right? So you type, you would actually write it there, 0.00000. Now 314 what? 42. So you multiply that with what? With what is the Young modulus? The Young modulus is given to be what? 7 times 10 raised to power 11. So that will be 7 times 10 raised to power what? 10 raised to power 11. Now, if you solve this very question, you'd actually get the answer to be what? To be 0.0001 meters. So you can actually write it to be what? You can actually write the answer to be 1 times 10 raised to power what? 1 times 10 raised to power minus 4 meters. And that is the what? That will be the extension. Just try to what? Just try to include units. Try to what? Try to convert all the, I converted millimeters to what? To meters before I can actually get this very answer. Please don't do that very mistake, because it will be a costly mistake and you will not be able to what? Able to get the answer correctly. Don't forget to subscribe if you've not subscribed, so that you would enjoy more of our videos. I think I would have to stop here tonight. But what I would just like you to do is to revise your notes, and I know you would what? You would gain more things and you would pass your exams this very year. Please, if you've not subscribed to this very channel, click the red subscribe button and also click the notification bell, so that you would be notified when we upload more videos just like this. I appreciate you, and if you want more videos like this, you can also check the description section. There are links there already that will help you on this very aspect. On this positive note, don't forget to invite your friends, and the name of this very channel is what? Do you know AGF?